Here's an example we did in class. This is the force table that most of you saw. This ring is balanced by 3 tension forces, one there, and one there. If you look closely, you can see the angles. This is at 0 degrees, this one's at 90 degrees, and this one, it goes past the 180 at 220, making this right here a 40-degree angle with the vertical. And because it's hard to see, I've made the tension forces visible. There's T1, T2, and T3. T3 is unknown. T1 is as you see written here. T2 is there. I told you the angles. Again, this is 0 and 90. They're at right angles. The vertical comes down here, and that's a 40-degree angle. So here are the steps. Draw XY axis so that one force is not on the axis. Make a force diagram. Calculate the components of the angled force. Let's look at that. Here is the force diagram. We don't have to rotate the axes, and we calculate the components of the tension force 2, and using our sine and cosine, that work is shown over here, and we end up calculating T2y, which is the y component of force T2, and T2x, the x component, and the calculations again are here. Here are the values for the x component and y component. That gets us to the net force equations. Now the quest is to figure out what that force is. That's on the y-axis, so this net force equation for the y-axis is written, and then step 4, fill in what we know. Well, the sum of the forces must be 0 because the object is at rest. T3 we don't know, so we leave T3, and then the y component is 1.01 newtons according to the calculation right there, but it's down, so I need to put a negative sign in there to give the direction. And using algebra to solve for T3, we see it's positive 1.01 newtons, and indeed it actually was 1.03 newtons in reality, very close. So this is just an example of force diagram and components, using trigonometry to calculate the components, and using the net force equations to calculate an unknown.